Hello and welcome to the Empower Continuous Monitoring System, or the CMS2. Now we call it CMS2 because it will concurrently analyze any two machines per set of hardware. So it basically takes in one phase of current for each motor and uses that and does either a rules-based system, an AI or machine learning system, either or and each of those systems as well, meaning that I can select a rules-based system, I can select machine learning only, rules or machine learning, or rules and machine learning. Part of what's very nice about that type of application and this type of application is that it takes anywhere from 30 to 240 seconds to do training. That means no more than 2 minutes to train on your system. Not hours, not days like most of the other systems. That has to do with our proprietary AI that is built locally on your system. So when you have one of these systems, it is literally on premises. It is not remote. It is not cloud. You can save your data on cloud. You can have it shared on cloud. You can do what you want in that area. But this then also works with our API. We have two basic API type systems. One is where you use our API to do the monitoring, which will email you conditions, etc., etc. This version will have, so that you don't need to use the API, it will have an emailable system as well. It all works with the Empower engine, our basically award-winning Empower system. So it sits there and it will be used to create your nameplate data, and it will also be able to, through the API, import the data and allow you to view it and troubleshoot and basically verify the findings with the Empower software, which comes with the kit. So let's go ahead and do a quick tour. It will, if it trips offline, which I did in this case, I shut it down and I've restarted it. So you can see it has brought up all of the data that we had previously set up. Right now, when I demo this, I'm going to be monitoring my laptop, so not a real motor. Then we're going to do a demo using two separate systems of this CMS2. So we'll have a total of 4 machines being monitored. One will be the laptop, and one will be an electric motor in the other room. So for our basically training and demo. So let's go ahead and walk through this. Auto off threshold means that it will take a look and it'll see if my current drops too low. It will automatically say, well, it's off. So I will get my blue LED like you see here. Good systems, green. Caution, yellow. And then if it exceeds a threshold, red. The other thing it does, especially in the rules-based system, it is going to auto-adjust for the noise floor. So if I have variations in the noise floor, it will automatically adjust the alarms to accommodate. It will identify that I have a raised noise floor as an anomaly. However, as far as troubleshooting, green, yellow, red, etc., it is going to leave it there. Now I have everything set up here kind of incorrectly for a reason. So we're going to use both. And we are going to, in this case, in our setup, we are going to go ahead and bind this one. So it's going to do my updates there. It's already set up, so we selected the rules-based for this one. Save yellow alert events means that it will detect anything that falls in an alarm versus an alert. Well, an alert versus an alarm, I'm sorry. An alert. It will identify that as an anomaly and will act accordingly. Analyze now will basically take a look after we've run for 120 seconds. It's going to use a rules-based only system, and it's going to troubleshoot using an Empower Lite algorithm. So we have that, and we're all set there. This all has to do with once we have any type of anomaly, we will be able to overlay, open it, separately to take a look at that specific data, including some conditions with it, and go from there. So let's go ahead now, and we are going to start the system. So let's go ahead and we'll record 30 seconds of training data. Now in the API itself, it will pull data into a folder on the remote machine that you can then view with the Empower system. But this by itself is completely standalone. The Empower system allows you to eliminate any type of anomalous conditions, meaning you can verify what everything's telling you using that software. You can view the spectra in different ways, and you get the more in-depth rules. Version 2.6, which will be coming, will allow you to look at both channels, because this data is kept in a single file when it's exported. So it basically means that I will have both machines on a single data set, sizing about 30 megabyte. So training data is done. So let's go ahead. We'll automatically train the models, which should not take long. There we go. It's been trained. It's done. It's all set. We have now set up so any machine, whether it's a standard induction across the line machine or one on an inverter, we're all set. So let's go ahead and start monitoring. Whoops. We'll go ahead and start monitoring. This is already bound, so it should be okay. And we can see that we have low current. Of course, I've adjusted these to get false data. So this is all deliberate for the purposes here. So we can see that information, and it's running. It's giving me green lights, meaning it has not detected any anomaly. So if it does detect an anomaly, and that anomaly falls within the first threshold, it is going to give me some other stuff. The other thing I didn't cover was the detection mode. We have sensitive, balanced, and conservative. So sensitive will mean a lot of false positives. Balanced means some false positives. And then conservative means we'll lean towards false negatives, meaning later stage conditions. So we'll leave it here, and it's looking for variations in all the peaks by over a certain dB. In the actual training for users, we will go through what those levels are. So we will give it some time. I'm going to go ahead and pause while we give it a few minutes to start collecting data. Then we can look at the features of the system after it's into its mode. Okay, we have had some time for it to catch up. Also detect at least one anomaly. So there's the anomaly here. Okay, so let's see what that does. So that anomaly will be on this one here. This is going to allow me to come over and do an overlay to see what caused the anomaly. So we can see this here. You can see the numbers are much lower. So whatever happened, and there it goes. Yeah, so some of the peaks went higher. And you can see that this is stationary now. So we can clear that. And then the other thing we can do is open it. And it is going to open a few things for me. One is it's going to open something where I can take a look at all the data. It's going to open channel 2 and channel 1. In whatever way I have it, I can then go in and take a look at it. So we're going to get rid of these two temporarily. Let's go ahead and see what this all looked like. So if I come in here, this will adjust in size. There we go. I can then come in here and take a look and see what my waveform looks like. This is what my laptop looks like as far as current goes. And then here is what the spectra looks like for it. So I can take a look at that real quick. None of that's unexpected. That is what a laptop looks like when it's running, or this laptop looks like. So let's go ahead. We can get out of there. There's a lot of other things going on in there as well. So it's still running in the background. There we go. Other things we can take a look at include the trend. Oh, let's go ahead and let's analyze. So analyze now means it is going to pull up a system in which it's taking a look and it's providing me the details of that system, including any of my alarms and alerts, watts, losses, etc. So it's going to show all of that stuff, including my alarm limits from what I entered, and etc. So I can zoom in and see how it did that and what my peaks are and everything else. And if I scroll up, it'll show what the labels are. So that is also transferable to the other system, meaning the API. So that's there. I can also take a look and see what my trend looks like. Let's see if I run into any. Yeah, okay. So we're fine there. That's that has to do with the amount of time I've had this running, and we are set where that is concerned. We'll take another look at some of the other stuff, but let's go ahead and we will now take a look at the API and we'll pull the data off of a machine. So we're about to set this up so it's running on 2 machines now. One won't be active, one will just be sitting there dead. The other one will be running off of an electric motor. It's been trained and it had been running most of the day yesterday for the demonstration. Okay, so this is 2 separate motors set up on the system. I did not change it over to demo or anything like that, so they're just showing motor 1 and 2. This one is on a system that's not connected to anything, so it's just showing blue. I can stop it from doing whatever. I can start it analyzing there, so it's going to analyze nothing basically. Stop it, of course. We'll bring it to a stop from analyzing, and then restart. We'll refresh it and start over. This one here, we're going to let it run for a few seconds. This one here, we can take a look at a couple of things and then view analysis here. So, okay, we are now, because I started, it is showing what the data looks like on the machine from the demo. Okay, so I have it running in demo mode, so it's now collecting stuff. Okay, so it'll still show 0 and everything because it's in demo mode. Up here, let's go ahead and we're taking a look at a machine. We've collected some data for a little bit. It's showing from the time I started. It's going to continue up, and when it hits 200, it will continue there. So we can, in the meantime, take a look at a few other things. We'll come back to this in a second. In settings, I can set up my email alerts just by setting up all of the stuff and what addresses I want it to go to. So the email alerts are going to tell me whatever the alert is, etc., etc. So let's get out of there. And then while we're in here, to pick these up, because it's looking for something very specific in the software, and then through certain ports that will be set up, and it has to be on the same subnet, meaning that I won't be able to see this on this software from outside the system unless I specifically request a version that does that. So this keeps it all on premises, and you would have to go through the PC or laptop or server in order to see this. This will also run on either Linux or Windows. So once I'm set up in here, I can take a look at, let's grab this one here, viewing the analysis. Take a second for it to go, grab the data, and bring it back. There we go. And it's going to bring it in for both machines. And I have the alarms deliberately set up, so it's showing this. Here we go. I don't have the watt set up on it. So here's my conditions, and then it'll show watts and losses. So basically it will keep track of that for both machines, how I have them set up. So there's the actual decibels. Here's the alert and alarm thresholds that I have set up for it, et cetera, et cetera. So this is, and you can see that the numbers are not exactly one or the other. It's adjusting for the noise floor. This noise floor here at minus 50, that will be immediately around the line frequency, out to 200 hertz, and then above 200 hertz to 5,000 or 5 kilohertz. So that's that. The other thing I can do is open up the spectrum, and it's going to go ahead and grab that. And it's moving as fast as my system allows it. And it will bring in the spectra for both machines, including where and what it saw the alarms. So I can then zoom in. This is the firing frequency of the drive. There's the 2-time. You notice that it's not perfect, so there's times when there's other things I'll want to do. So there's that. And then finally, I can come in and say, grab me 120 seconds worth of data. And I'm going to allow it to do that. There it goes. It's telling me where it's put it. And now I'm going to pause as I start up the Empower software and show you how it collected the data. Okay, so here we go. I am going to go ahead and open the analysis. I'm going to pause while I do that because this is all on a development machine. So bear with me while I do that. Okay, so just to show how it's done, so here is the data. We will go ahead and open that data. We will select the motor 2 JSON for that, because that's all imported is the nameplate information. Just go ahead and we are going to go and take a look and see what came out of it. I have a VFD driven motor with it, has some issues with it, and it is varying in speed just a little bit, so it will look pretty ugly. And here we go. So it's opened up the data, like I said, pretty ugly. There's the stuff there. It's all based on, this should be the actual. Let's go ahead then and have it analyze that data for me. It's going in now and it's selecting the running speed and a bunch of other stuff for me. It's going to do its best, seeing as the line frequency is varying quite a bit and there's a lot of noise present. You can see this is still running fine in the background. Whoop. Okay, went ahead and it's picked everything out. Here's my watt losses, and here is the total watts loss. So let's go ahead and analyze it based upon the hours and everything else. So because of that machine, it's not huge, of course, and then everything's set up. Let's see, yep. And that's it. So we have that data there. So we're able to pull in the data as often as we wish, look at it remotely to do verification, and then, yeah, there is a casting void in that machine. It is vibrating. I do have both, and then the drive's not set up properly, which is why we have these high peaks here. So that is a quick view of the system, and that is basically it. So if you have any questions, let us know, and we will be more than happy to answer them.